Hi everyone. Hi everyone. Hope you guys are doing fine. And today we will discuss on different scenarios of distributed database. In the last video, actually, we have seen like what are the major approaches when we can or we are looking for scalable system, especially we considering the database server. And there actually we discussed on two approaches or techniques. One is master slave, another one is like sharding techniques. So we'll be today focusing more on this sharding technique. But before going to get deeper, we would like to discuss few points. So there are three different scenarios actually we'll be discussing. First one is like if you just consider this mm, consider this diagram. Suppose we have a service or a server, and there is a service which resides in the server, and the service is requesting some is trying to do some read operation from the database. Now, this is fine unless and until we have a huge amount of requests, and we are considering our request is not huge in amount. But the question is the database is full. The database is full with its you can say like it got a good amount of capacity. So what we can do at this particular scenario when database is full, we have really one option which is a very naive option, that is we can add more memory when the database is full and we do not have any chance to have a big amount of data in the future. So we can go with vertical scaling, that's perfectly fine. But what happens if this is not the case, and the case is we got huge amount of read requests, which makes our server, database server, overloaded. And machine, database machine means we are talking the server is unable to handle the requests. So in that scenario, probably we can create some replicas, and those replicas will have the same content which the original database is having. So the replicas can be communicated, can be routed through a load balancer, and we can read traffic and make sure like the loads are getting distributed evenly or uniformly. So that could be an approach. Definitely that could be a probable solution in this context when we have a huge read requests, but we are not claiming that we are increasing our data. That means in terms of the capacity of the database, we are not commenting anything. Rather, we are commenting on the incoming read requests. So there, this approach could be a tentative approach, which makes the solution. Now, the question is, definitely you will be asking that what is going to happen if our data grows heavily, and we expect to grow heavily. So in that case, probable solution could be sharding. So what does that mean? We already discussed in our earlier video. Sharding means we are splitting our data into multiple capacity. Capacity means, for an example, we have split our data in 3 databases. So the capacity is going to be 3, right? But how to contact the sharding, we already discussed that how to pull data from the correct database, that can be ensured through partitioning key. Now the question is, what is that partition function? We talked about partition key. What is that exactly? So if we go to our previous diagram, we can probably make it more clear and have a nice understanding on this. Suppose we have shard this database. So this database is having some data as we have discussed. Suppose this is containing a data, and if we consider more into this diagram, okay, let me do one thing. Let me make this diagram or copy this diagram, and I don't know whether this is going to be copied or not. If I open a paint, I can probably make it more clear to you guys. Oh, sorry, that's not the right thing. So what I'm trying to say here is, let's use me to cut this diagram and put over here, right? Copy, and let me open up paint and paste it over here. So what I'm trying to establish here is, like, suppose we have a service and we created something called data lake. So I'm saying, like, this is something like we have a key and we have a value. The table would look like this, and this key is basically our partition key. And the same thing goes over here. We got a key, we got a value. We got a key, we got a value. And the nature of key, suppose it goes from A to I, and it is having something called I to, for example, O, and it is having, suppose, O to Z. So this is the distribution. We are making it in this way, and we are ensuring, like, whatever is happening between A to Y will lie in this database. So any key which is having, for example, A121938. So if the service is having the knowledge, like, this key remains in this section, then he can route the request in this database, right? So based on that, he can make the decision. That is perfectly fine, right? Now the question is here, actually, what happened? Now, whatever the request comes, we normally put that into a hash function, right? Suppose we got something called, for an example, hash, and we have some number, right? Now this is giving us some value, right? Now the question is, if we get a remainder operation over here, and if we get 1, then we can assume that this is a database which is having index 0. This is a database which is having index 1. This is a database which is having index 2, right? So whatever the request is coming, and that request is having a remainder value 1. So this is our partition function. This function is actually our partition function. Now this function gives us some value, and based on that value, the requests is going to be routed over the correct database. So the request is going to happen over here, right? Because it is the database which is having the index 1, right? So this database, as we discussed earlier, like sharding technique, basic assumption is like all the database is going to be master in nature. So every request will have equal read and write capability. So it will read from this database, it will write in this database. So now, if in this way, actually the partition function comes, but there are some disadvantages with this approach. And those disadvantages are nothing but, for an example, this is definitely create some hotspot. For an example, concentration of more keys in one machine. If it occurs like this, then it will increase the load on that particular server, which is not good from the design perspective. So that is going to be one of the cons. But we have an alternative also. So The alternative is solution to this is consistent hashing, definitely, which we will discuss. But this is one of the cons which we need to remember. Another thing is like the question which would come, like in which situation this type of technique, as we discussed, which we used with the partition function, is going to be a well fit. That is, it is going to be well fit only there when the keys are well distributed into this hash space, because we are using a hash function, and based on that we are fetching the remainder, and that is basically the partition function. And partition function, actually, if you see it more clearly, we are assuming, based on our approaches, we are assuming whenever we are doing this, that means we are assuming that every machine will have an equal distribution of keys or partition keys. So that's the basic assumption. On top of that, this concept relies, or this concept will work fine. So when the keys are well distributed, then definitely this approach is good. Otherwise, if it creates hotspot, then we need to rethink, we need to think an alternative. And consistent hashing could be a good alternative for this approach. So we will be discussing consistent hashing for sure. Now, for the time being, I think we are done. And if you guys have any comment on this, so you can put your feedback and your suggestion into the comment section. Hope you guys will like it. Thank you so much.